knowingly or unknowingly, how the methods and practices of Western academia misled the world. Um, that is the topic I'm going to discuss today. In another way, we can um, look at these methods and practices, how they contributed to the stagnation in fundamental science. And so nowadays, like when you see um, the talks by different within the scientific community, a trending perception in the scientific community is that like there is a stagnation in fundamental research, particularly in the area of physics. So do we really have a stagnation, or are there any alternative theories at the fundamental level that are being ignored at present? So if there are some alternative theories, but why you haven't heard about them so far? So those are the topics we're gonna cover. This is part of the series I'm giving, series of talks I'm giving. This is talk number 8. Today is January 5th, 2025. My name is Karunakar Masakatla. In a simple a theory I proposed earlier, when you look at why species divided into gestation and egg laying, when you look at all the species which has molar teeth, where they could chew the food into small pieces and digest, they adapted to gestation. And then the species which don't have molar teeth, which cannot chew the food into small pieces, they basically ingest large chunks of food, or like a whole animals, like snakes, they just swallow, rats or anything, whole body they just swallow. So in those cases, um, they adapted to egg laying. So this is the main, like major kind of easily explains how the species got divided. And this theory I proposed 6 years ago in a PhD preprint paper, but there is no adaptation into the academic circles yet. And then when you look at the gravity, um, how it varies with the density of the matter. So we see the mass defect in nuclear reactions should actually be considered as change in mass when object disintegrates. The nucleus of uranium or any atom, when it disintegrates, we see the mass deficit in that resulting components. So that, but number of protons and neutrons are the same before and after the reaction. So the amount of matter is the same, but the mass change. So that actually change in mass with the same amount of matter basically invalidates the definition of mass. So that concept of deficit mass invalidates the definition of mass. So density of the nucleons, both protons and neutrons, determines the mass and the gravity of the objects. So if the nucleons are closer together, that object measures more mass, and then if the nucleons are further apart, that object measures less mass. Jupiter, um, nucleons are further apart in the form of elements. When that collapses to neutron star, all the neutrons are closer together, so that with the same amount of matter, it generates more mass and gravity. So that is what I proposed a theory that was 15 years ago. And when my other research, where I combined supercontinent cycles with Manvantara cycles, Manvantara cycles were described in ancient Indian texts as causing mass extinction at the end of each cycle. Snowball events at the beginning of each supercontinent cycle causes a mass extinction. Long periods of these cycles and other similarities made me to conclude that these two cycles are the same. Additionally, I propose that like two galactic cycles cause one supercontinent cycles. Supercontinent cycle is not an independent thing. So when the solar system goes around the galactic center, super volcanoes or mega blobs form um, on the earth in the mantle, and then they kind of disperse and then make when the blobs interchange with the troughs, they assemble back the broken plates together as the supercontinent. And then the beginning of from my research, I found that like a beginning of plate tectonics is placed at 2800 million years ago. Since then, 6 cycles were completed and each with a duration of 430 million years. Present is the 7th cycle. So, description of 7 earths in the Hebrew text and 7 Karshvars in Zoroastrian texts describe the same cycles, supercontinent cycles, along same as the Manvantara cycles. So this theory I proposed 25 years ago, but bits and pieces, parts of the theory got absorbed into um, different theories, but whole concept was not incorporated into the mainstream science. So why they ignore a research that's out there for so long? Not only my discoveries, these 3 discoveries, there are plenty of other discoveries um, out there. Either there are plenty of alternate theories to explain many observations in the nature, and some of them are better than the ones that are part of the academic curriculum. Then why these theories are not part of the um, curriculum? So why continue these theories, even though there are some cases better than what is being taught in the academia, but they're still ignoring these theories. Why that is happening? The main um, culprit um, for this stagnation of science is peer review. It is almost impossible for an outsider to get their articles published in a popular journal. Peer review makes an outsider to go in a loop endlessly from one journal to another um, in their effort to publish their research. And it is the first and most effective cause for hindering the advancement of science, because it will never even like ideas could come from any corner, right? Everybody is educated, university educated, so why the discoveries has to be recognized, only those discoveries coming from the academia. So whatever that people outside the academia, whatever the discoveries they make, it's very difficult for them to get publicized or published in a journal. So the peer review concept stops the uh, to popularize any discovery by outside researchers. And then second thing is the absence of theoretical exploration. So publishing an article with pure um, thought experiment is difficult due to the following reasons. So requirement of data to support any hypothesis in most of the journals, like thought experiments, if you write an article with a thought experiment, not many journals will accept, like they want data to support the theory. Um, and then if somebody has a theory, like they have access to data, where university circles, they could experiment things and then generate the data. And then when they submit the paper, journals ask them to come up with an hypothesis to explain the data. But some people, some scientists are good at experiments with instruments, and then others doing thought experiments. So somebody might generate the data, do experiment, but they might not be able to explain in a coherent manner what the data represents. But others look at the data and then just observe and then find a pattern in there and then explain, formulate a theory. The gestation discovery I made, I explained. I just kind of browsed through Wikipedia articles about species and how their dietary habits, and then how the gestation reproductive processes works. So I just come up with a theory. So data out there, it's only the linking and connecting the dots is the important thing in creating a hypothesis. So less number of hypothesis journals kind of um, hindering outsiders to publish any articles, express their research. So publish the data. So what my suggestion is, um, experimental data should be published as it is without forcing them to formulate an hypothesis, and then let the outside, whatever, let the world, whatever people who are interested in science, they look at the data and they formulate their own hypothesis. There should be multiple hypotheses for any set of data. Let people come up with different hypotheses, then the best one wins. That should be the ideal environment. And then the other thing is, these journals and articles. In some cases, one article is like $25. So for the outside researcher, spending that much money is kind of not possible. And then uh, so the another hindrance for the advancement of science is, some of these preprint servers, closed or moderated preprint servers like arxiv.org, are a bane of science. Basically, you can't publish in a journal. You can't even post your work in a preprint server. Even though your theory might explain better than what is out there in the academia, you can't show off your work to the public. And so these kind of restrictions, they put themselves walled inside some kind of enclosure. They're not able to see what is outside. So these servers are the second most worst thing to happen in science after peer review concept for publishing the research results. There should not be any peer review. Just just publish the data, publish different hypotheses. The best one wins. The public will decide which is good and which is bad. And then the another thing that is hindering the progress of science is Wikipedia. Wikipedia gives the impression that the science is a set of well-defined theories. So when you say like, oh, just go into Wikipedia and then see some theory, um, it gives the impression that that's the standard thing. In reality, there's no standard thing in science. Drawbacks of using Wikipedia for science is a fluid thing. Like you may say, like there's a prominent theory today, tomorrow that might get dumped in trash. So it's a very fluid thing. Um, so a lot of things change overnight. So updating all the pages to incorporate new discoveries is difficult. If one theory proven wrong, and then how they connect that theory to different concepts um, in physics, and then how they will be able to update all those pages is not possible. So Wikipedia fluid things are not suitable to display at one place. Absence of importance to alternative views. Wikipedia doesn't give so everything is like a journals, the academic textbooks, Wikipedia, and then preprint servers. Everything thinks in the same line. So where is the possibility for the alternative theories to come up? Mm, so that's why Wikipedia is not suitable for reporting science, so, but it could be good for historical data of sports and games. Hey, who won in the Olympics or which sport? Just go search for that, and that will never change. If somebody wins a game in a year, that will be written in stone. That will never change. So those kind of data is good to be part of Wikipedia. Information on the properties of elements like iron, nickel, what are their electron structures, so the color and everything. So those kind of things will never change. So those things could be made part of the Wikipedia. Behavioral anatomical information of species. So these kind of information can be hosted on Wikipedia, but not the theories themselves. So that's not a good environment to host the science. It's not even suited for historical information. History also you can't describe in, we might discover something new that might dethrone like whatever the existing assumptions are. And also history can be viewed from one area in one way and then another area another way because there are a lot of conflicts in history. So Wikipedia is not suited for science or history. It's only suited for sports or properties of elements and properties of species. And then another thing that is hindering the science is plagiarism, plagiarism check of journals and other academic circles is a double-edged sword. That's how I believe. So what they do is academia checks the presence of their work in academic works and the non-academic works, but they won't check the usage of non-academic works in their own literature. If somebody has a talk and that has very significant discovery in science, somebody in the academic circles later publish after a couple of years, they might publish the same thing and then they won't report to the talk anymore because that is the original discovery. The citation issues. Another thing is like academic research won't cite the works outside their own circle, but they take the cues from books, videos, comments on social media and other non-academic sources to advance their research. Yeah, most people say they discovered something, but they most cases in all this academic research they take cue from somewhere and then they won't cite it. That's how that's how so it's not original discovery. um, Original discoveries, if they are like that much of creativity is there in academic circles, science won't stagnate for centuries, like almost 100 years. There's no one. People say not much progress in fundamental physics, and then yeah, when you look at the gravity, like 200, 300 years old from Newton time onwards, and then so many flaws are there in the current um, current theories of physics. And then popular media is also covers only the research coming from academic circles. If you and me, the general public, are citizen scientists or independent scientists, however you call it, if you discover a major discovery, you send it to news media, they just ignore it. They never report on these discoveries. Um, and then libraries also, they buy only the books these academic circles create. So the same kind of theory gets looped through journals, books, and libraries, Wikipedia. They all go in a circle. That's why they are not going anywhere. They are just everything led into a ditch. They are just sitting in there. So mm, that's why I kind of created a movement, theory of everything by 2025. Um, I wrote an article in December, and then planning to make it as a kind of a movement to bring attention to what is out there, what are the alternative theories, how can we, what is the right direction for achieving the theory of everything. I'm thinking my book, The Gravity from a New Angle, and whatever I wrote in many articles after the book, explains most of this theory of everything. If not that, a clear direction will emerge by end of this year. That's my kind of, I'm putting emphasis on bringing this outside, um, want recognition for this outside work to happen by this year. So, on the side note, is this stagnation only in physical sciences, biological sciences, or that extends to social sciences as well? So, yeah, same kind of like tribe thinks in the same way. So, even the social sciences is no different. The why? So, because I'll give an example here. Why the history of India goes back only about 500 BCE, even though it has vast amount of ancient literature, including well-written genealogies of kings. Um, so it has tremendous amount of literature, Puranas or Kavyas, and they describe genealogies of the kings as well, starting from Kali Yuga, 3102 BC, before Common Era. But all the thing these modern historians ignore. So why this is systematically happening? I'll explain here. So an Indian king, Sandrocotus, was described in Greek texts as the contemporary of Alexander when he invaded the India. So this Sandrocotus was identified as Chandragupta Maurya of Chandragupta of Maurya dynasty because of the similarity of the name. So they thought like Sandrocotus is Chandragupta, similar sounding kind of name. So they thought like that Chandragupta of Maurya dynasty might be the one. So they kind of calculated the time from that time onwards and then went back. When the comparison was established, Chandragupta of Gupta dynasty was not known to Indian history. That's what a lot of Indian and Indian native historians um, kept saying. Like so later, when Chandragupta of Gupta dynasty was known through books or edits or whatever the sources he was discovered, Indian scholars realized that Chandrakotis was in fact the Chandragupta of the Gupta dynasty because the genealogies matches with this king in chronological order. So the genealogy of the kings from Mahabharata onwards, all the dynasties, when Gupta king was equated with when um, Alexander invaded India. So when the Gupta, Chandragupta of Gupta dynasty is the contemporary of Alexander, then everything matches going backwards. So, but mm, still, this error was not corrected to this date, resulting in the assumption of Indian history just few thousand years old. Traditional text places the Mahabharata war at 3162 BCE, where the academic work puts it around 15 BCE. So a 1500 years difference. So they basically, current Indian historians um, eliminated 1500 years of history of India, and then just because of that error. So this is how the academy circles work. They basically ignore the outside criticism, outside theories, and then they go about with their own assumptions and theories. So that needs to be changed. So there is no stagnation in fundamental research. See, uh, see, if something wrong, people will inevitably find a solution to that issue. So the world cannot live this long with so many errors in physics. Present theories are not providing satisfactory explanation to many observations in the nature. There are plenty of alternative theories in books, articles, and videos outside the popular media. These theories are not being looked into. They should be made part of the academic curriculum. So that is my attempt at bringing awareness to whatever the alternative theories are there to the academic theories. So so that so what needs to be done to make these alternative theories to be part of the science? Yes, I will explore that question. So this is how the systematically outside theories are being ignored and what is hindering the science. That's what I tried to explain in this talk. And then on the next talk, I will conclude the series by providing an ideal environment. What should we do to kind of make science a collaborative effort between academia and then outside experts, and then formulate a mm, effective theory, what is convincing theory that describes the natural phenomena. So these are the talks I gave earlier. This is the eighth talk. Um, Present talk is the eighth talk, and then these are the previous talks I gave. And then so I covered so far my discoveries in the earlier talks, and then what the drawbacks in the, publishing the research results. That's what the present talk did. And then next talk I will give what is the ideal environment to publish the research papers. And thank you very much.